Hi, this is Professor Rakesh from IIT Guwahati. This paper is an outcome of joint work with IIT Guwahati, NTU Singapore, and University of Technology Sydney. The title of the paper mentions about space efficiency. Traditional mutual coupling reduction techniques like EBG, neutralization lines require extra space for realization. In our case, we have integrated metagrid lines in the ground plane itself, so no extra space. We have observed that metagrid lines exhibit single negative metametric properties. Hence, it blocks young wave propagation and enhances isolation without increasing antenna footprint or size. As a proof of concepts, we have implemented two-port antenna array with meta-grid line integration in the ground plane. This picture shows two CPW-fed elliptical printed monopole antennas with meta-grid lines integration in the ground plane. It's a very compact antenna array with a volume of 0.02 lambda I cube, and end-to-end spacing of the antenna array is just 0.015 lambda h. Lambda I is calculated at 3.46 gigahertz. Mutual coupling is less than 20 dB. This picture shows annular ring slot fed two-port cylindrical DRA array. Volume of the antenna is 0.035 lambda I cube, and gap between DRAs is 0.091 lambda h. Lambda h is calculated at 5.65 gigahertz. Mutual coupling is less than 16 dB, which is quite acceptable. Mr. Mohit Misra will show the fabricated antenna and its testing.
We have used Keysight Fieldfox microwave analyzer N9952A to measure the S parameters of our antenna. This is the S11 corresponding to port 1. Now I will showcase the S21 parameter between port 1 and port 2. So this is S21 parameter. Now I will show our antenna whose S parameters I have just measured. This is the uh, top layer of my antenna under test, and this is the bottom layer of my antenna under test. This is the radiation pattern measurement setup for our antenna. Here at one end we have used standard again horn antenna, where we are feeding the signal through this cable. This cable is connected to the Rode and Schwartz signal generator. This is Rode and Schwartz SMBB100A vector signal generator. From this signal generator, we are feeding signal to the standard gain horn antenna, and at this end, we have mounted our antenna under test at the rotatable mount that can be rotated like this in this plane, and corresponding to each angle we are detecting the signal level using Agilent CSA spectrum analyzer. Antenna under test is connected to this Agilent CSA spectrum analyzer for detecting the level of the signal corresponding to each and every uh, corresponding to angle. We are taking reading at an interval of 5 degree in this plane. This is the uh, arrangement for measuring the radiation pattern in phi is equal to 90-degree plane. This is the two-port dielectric resonator antenna array. This is the top layer of the fabricated antenna, and this is the bottom layer of the antenna. We have followed the similar steps for measuring the S parameters and radiation pattern of this antenna array.
Welcome back. This is Professor Rakesh. Now we'll discuss about the performance of our antennas in MIMO system. Let us consider 2 by 2 MIMO system, which consists of the transmitter and receiver with two antennas and a channel. Its performance metrics are multiplexing gain, diversity gain. Multiplexing gain can be obtained from its channel capacity. In line with MIMO system performance metrics, MIMO antenna performance metrics are channel capacity loss and diversity gain calculation. Two fundamental questions are how much is the channel capacity loss due to antenna correlation? Can our antenna achieve maximum diversity gain of 4 of a 2 by 2 MIMO system? For that, we need to obtain the antenna correlation matrix. Antenna correlation matrix can be obtained from the envelope correlation matrix. So this envelope correlation matrix can be accurately obtained from the 3D radiation pattern of the antenna. For two-port CPW monopole antenna array, ECC is less than 0.026 within the bandwidth of the antenna. Channel capacity loss is 0.075 bits per second per hertz, which is quite low and very good. This MIMO antenna can achieve maximum diversity gain of 2 by 2 MIMO system, which is 4. For two-port DRA array, ECC is less than 0.046 within the bandwidth. Channel capacity loss is 0.1727 bits per second per hertz, which is also quite good. This MIMO antenna can also achieve maximum diversity gain. Thanks for watching.